This is the third video for section 6.1. Here we're going to talking about inverse tangent function. So on the screen you see I graphed one period of tangent function. So when we're looking at the tangent graph, as long as we're looking at one period, the graph is really nice one-to-one function. So for the tangent function, I do not need to trim anything. I can just use the entire one period to find its inverse function. So here I have 3 key points. The first one is pi over 4, 1. And the second one is 0, 0. And then the next one is negative 1 pi over 4. I'm going to write it inside. Negative 1 pi over 4. I'm sorry. Wrong order. Negative pi over 4, negative 1. Okay, so now we can use those 3 points to graph the inverse tangent graph. So I have pi over 4, 1 becomes to a 1. Pi over 4. And then 0, 0 becomes to 0, 0 again. And then negative pi over 4, negative 1 becomes to negative 1, negative pi over 4. I'm not going to label them because it's kind of tiny. Okay, so I'm going to connecting them. However, before I connect them, I also need to write down my asymptotes from the original tangent graph. So my asymptotes at pi over 2. Okay, now I can connect everything. Since we didn't trim anything, so we still have a continuous graph with 3.1 pi over 4, 0, 0, and then negative 1, negative pi over 4. And then the asymptotes pi over 2 and negative pi over 2. So we can call it either tangent inverse or arc tangent x. So by definition, or more like officially, when we're talking about inverse tangent function, we normally call it as y equal to tangent inverse of x or arc tangent x. That means x equal to tangent of y with the original restrictions, negative pi over 2, less than y, less than pi over 2. So that means the range for the inverse function is going to be negative pi over 2 to pi over 2. The domain for the inverse function is going to be negative infinity to positive infinity. And then we still have the horizontal asymptotes, and then we have even odd properties. So y equals to tangent inverse of x is an odd function. Okay. So for this one, I have 2 examples. We can show you how to looking at those, or how to use the inverse function definitions to solve any problems. So find value for y equal to arc tangent of -1. So by definition, that means tangent of y equal to -1. Tangent of y equal to -1, y has a reference angle of pi over 4 is negative. That means it's going to be in quadrant 2 or quadrant 4. Since when we're talking about the range for the inverse tangent is going to be between negative pi over 2 to pi over 4, so y is going to be in quadrant 4, but negative part, so it's negative pi over 4. Okay, then the second example we have is slightly different. The formatting is I want you to find the theta, where I know theta equal to tangent inverse of square root 3. So that's the same thing. I can rewrite it as tangent of theta equal to square root 3. Then theta has a reference angle of pi over 3. Positive, that means it's in quadrant 1 or quadrant 3. And then we cannot have the range for the tangent inverse is going to be between negative pi over 2 to pi over 2, which means negative of the pi over 4, negative sign of the pi over 4 to the positive of the, negative of the quadrant 1 to the positive of the quadrant, negative of the quadrant 4 to the positive of the quadrant 1. So we're going to using the positive of the quadrant 1, pi over 3.